And what do we say when the stream starts?
What up, chat?
What up, chat? Any chatters in chat?
What up, chat?
Any chatters in the chat? Chat, do we have any chatters in the chat? Any chatting? Okay. Cringe. Based. Okay. Do people still say based?
Yeah.
No.
Conflicting influence.
Okay, so fact check. I just said it, so yes, people still say it. Okay. You are working on your midterms. If you're having a problem with your midterms, you're talking to one of the two of us, and there's going to be something turned in. After they're turned in, I'm going to make sure the rubric makes sense for what you turned in. But they're going to be about 4 pages of text in Markdown on GitHub. You're going to send me a link on Friday by noon. If you need to know if I got the link, you should send it by Wednesday by 1 so we can check in class.
Wait, don't we have? I don't think we have class next Friday.
Yes. Yeah, it's just due at the same time there would be class. I don't want to give you until the Monday, then you're just going to work on it over the weekend. Yeah, it's due Friday. It's due Friday. If you want the day off, turn it in early. Okay, so, do it. Okay, the plan is, and 2 of you are so lucky to have me for CS 151. I figured out this trick with the CS 151 midterms, where I can just give you the score that I think you earned, and then I can curve it to what you want to get, right? And I can email all of the other faculty and tell them the pre-curve score, and they'll think I'm mean, right? And then I can give you the post-curve score, and you'll still get high grades. So we'll get credit for me being mean and for you having high grades at the same time. It's like cheating, right?
It's like win-win.
Yeah, right? Everyone will be like, ooh, Cal, ooh, I can't believe you gave everyone an F minus. That's not even a grade. And I'll be like, that's right. An F minus is 97 out of 100 points in this class. And they'll be like, that doesn't sound like an F minus. So, anyways, that is not encouragement to try and get an F minus, but there's this thing I learned that once I started curving scores, I don't have this thing in the back of my mind that's like, are you being a complete jerk right now? I just tell you what I think about your writing, and I think it's probably more beneficial for you to get some actual feedback than for me to be hanging out. Okay. All right, so today we're learning pandas. Why are we learning pandas? It's probably the most useful thing that runs on computers. It is, quote, a fast, powerful, flexible, and easy-to-use open-source data analysis and manipulation tool. Now, students, that says easy to use. It's not me that's saying it's easy to use. I have a citation, right? So when I say it's easy today, you're not allowed to argue with me unless you have a citation, okay? So you didn't think of this one, right? This is the problem with allowing citations, right? My citation says it's easy to use, okay? And I think pandas is why data science is a big thing now. I don't know for sure. What's it stand for? So a lot of people think it's for the cute cuddly bears, right? No, it stands for panel data. Isn't that way less cool than the cute cuddly bear?
Way less cool.
Yeah, and its number one competitor is called polars, and that one is named after the bear. So if you put in polars here, they got the bear right there. Right, so typical pandas L. Anyways, so pandas in the olden days, which I think I mean 2005 until 2025? Yeah, because it just changed. It used to just be window dressing around NumPy. There was just the NumPy n-dimensional array. They were restricted to be 2 dimensions because it's a panel. So you have rows and columns. And it just does things like have row and column labels and then has a bunch of ways to join data together, right? Now it's built on this super high performance back end thing called Arrow. It's wicked fast and the basis of the data science boom. You don't have to worry about that stuff, but I want you to know that pandas is awesome. okay? So it's easy to use and it's awesome, all right? Are you all taking notes?
Mental notes. It's
Okay.
easy to use and it's awesome.
Yeah, okay. So there's a lot of people on the internet that say they're Python data science educators, and all of them seem to be scared to death of writing code. I told them I made you learn to use Git at the command line, and they almost kicked me out of the Discord server. And I told them it builds character. So, anyways, they're all teaming up with you against me. But what they told me is that I have to tell you that pandas is just like spreadsheets. Do you all know what spreadsheets are? Do we love spreadsheets, folks? Oh, really? You hate them?
The data and just without doing anything.
It's nice,
Oh,
I
yeah.
just don't like it.
It's nice, I just don't like it.
Like,
Yeah.
it
Depends
looks
on the
weird.
tool. Like they formatted Excel kind of weirdly since the last time I took an actual class on how to use it, which is annoying.
I have the perfect solution for you. We're going to use pandas instead, then you can format it however you want.
Oh, sweet.
Yes. Oh, sweet. Okay. Pandas, easy to use, awesome, sweet. Okay? All right. My claim is versus Excel and Google Spreadsheets, you can do things automatically. You can write a script that runs over more than one type of data. You can do things repeatedly. You can run the same script more than once. And you can do things consistently. By which I mean, when I learned Microsoft Excel, someone would tell me, click this key and then go down this menu, and then we would find out about 20 minutes later we had different versions of Excel, right? And I'm still mad. Okay. In the olden days, back before I was based and I used Excel, I mostly used spreadsheets to make charts. Now I don't do that anymore because I know how to use pandas and matplotlib. Okay, so pandas works very well with matplotlib. In fact, pandas works better with matplotlib than it does with NumPy, which is very surprising because no one planned on that happening. It just was this naturally emergent property. You may remember when we were doing matplotlib, there was a bunch of annoying things like, how do we get labels on all these axes? Well, if you do it in pandas, it just happens, right? Now, sometimes it happens wrong and you have to go fix it, right? But that's still better than it not happening at all, maybe, right? Now, I'm always worried about my value added as an instructor that's basically regurgitating things that you can find for free on the internet to you. But if you go into the NumPy Quick Start, or perhaps the Absolute Basics for beginners, there's only two other libraries they tell you to use, and one of them is pandas, and one of them is matplotlib, which is like up here somewhere probably. I don't know, because my screen is zoomed in too far. Matplotlib. There it is. Okay. So pandas and matplotlib are almost just part of NumPy. I'm teaching you NumPy because scientists are supposed to know NumPy. Am I a real scientist?
No. Basically.
No. So I don't know. Right? No, I'm not. Computer science. Science is in the name, therefore I'm fake, right? Okay. Is political science a real science?
No.
Right. So we understand that, right?
Right.
Is we probably shouldn't pick on anyone else.
Biology?
That's fine, right? It doesn't have science in the name. Okay. Why not pandas? Pandas did not have a competitor until quite recently. It does now. There's Polars. Polars is probably better. I don't know. I played around with both of them. The reason I'm teaching you pandas is I think if you go to grad school, your professor, who's your advisor, will know pandas and not Polars. That's my theory. So I'm teaching you the one that I think other people will use. If you go to grad school in computer science, your professor will be using Polars. But it's going to take Polars 5 to 10 years to catch on with other people. That's all. We have only calculated and plotted data we have typed in ourselves. Yuck. Do you all like typing in data yourself?
Mm-hmm.
I watched you do it last class.
I didn't like it.
You hated it? Are you a hater? Okay. Were you drinking your Haterade the whole time?
Mm-hmm.
Yeah, I'm fresh on the Haterade these days. So first things first, let's install pandas. Everyone would like to open up your little command line terminal and get pandas a-going. Here, I will do it on my computer. Python 3m pip install pandas. I already have it, but in my defense, I have to use it like all the time. In fact, I used it last class. They didn't know it. The plots I showed were made in pandas. This might take a moment. Okay. I'm going to keep talking while that's installing, because you don't have to start typing yet, though you can start typing. So while that's installing, perhaps we make a new tab, and we nvim bear, which is short for panda bear. So we have bear.py. Inside my bear file, I'm going to import numpy as np, and I'm going to, by convention, import pandas as pd. I really wish people just used the first two letters, their first and last, but that's not what happened. It's by syllable somehow. This is how we can use pandas. I'm going to go ahead and I'm just going to do a total yoinkaroonie on this. I'm just going to yoink my pandas stuff, right? So what are we doing here? I'm inserting. I said yank my pandas stuff. I meant numpy stuff. So what is this? This here, highlighting the insides, not capturing the parentheses, that is a list of Python lists. That is the Python thing. I'm putting that inside a numpy array, and that's going to become the numpy thing. Then I can do that one more time, and I can say pd.dataframe, so the data frame being the thing that goes around the array, and that's going to give me a pandas data frame. And let's take a look at this. I'm going to print this thing out. I think that's what I'm going to do. Okay. You all have been okay on installing pandas? Okay. So that means that if you do bear.py, import numpy pandas, get some data frame, we can print this thing out. Python bear.py. And that's what a data frame looks like. Some things I notice, that looks kind of nice to me. It's kind of easy to see that. Things are lined up. Maybe it's less annoying than it used to be. We can compare it one-to-one. Because we can also print the array. How do I run this thing? So, like, I think the array is more cluttered visually than the data frame, and so I don't know, maybe that's one of the first benefits we begin seeing here. There's a few other things to look at, though. There are column, referring to the vertical ones as columns, like the columns that hold up the Acropolis. Are there other columns? Petra? There's Petras somewhere. Petra. In Jordan. There's columns here. There they are. Okay. So columns all around the Mediterranean. Possibly other places than the Mediterranean. I don't know. So you have these vertical columns, and they're numbered. Now, these numbers on the left-hand side kind of make sense. That's the number of the bracket. But actually, we should probably have names for these, where this is the cutoff and this is the percentage. We actually can do that in pandas. We can add column and row headers. We're not going to do that. We're going to do nuclear engineering, or what some people say is chemistry, using a little thing I like to call the periodic table of the elements. Now, folks, I want to hear your hands come together to welcome the periodic table of the elements to scientific computing. All right, yeah, very good. We love the periodic table of the elements, don't we, folks, right? It's periodic, it's a table, and it's of elements, right? That's three good things all there right next to each other right at the beginning, right? Name one other thing that has three good things about it. Right? No one can come up with anything. So, is too slow. And the things are? Easy to use.
Easy to use.
Sweet.
Sweet.
Awesome.
Good for charts.
Awesome. Good for charts. That's four good things. It's different than the periodic table of the elements. Okay. Okay. So when I'm working with pandas, I usually do what everyone else does, which is I import a CSV style file. Some people call those Calvin separated value files. It actually stands for comma separated values, right? The reason people started calling them Calvin separated values is so many times I would make them myself for my classes that we just called them Calvin separated values because I was the one separating the values, right? Let's take a look at a periodic table of the elements.csv. I'm going to open this in a new tab. This was basically just the first Google result for periodic table of the elements CSV. But let's take a look at this. Oh, it's showing up as kind of a markdown table. Well, let's look at it raw. Here's just the text. And what we see here is we see values that are separated by commas. We have an atomic number, an element, a symbol. These are all column headers, right? And this is, oh, my legs are getting tired. Oh, no. Okay, I'll be fine. These are also comma-separated values. I have a 1, I have a hydrogen, I have an H, I have a 1.07. Something to point out about this. In a NumPy array, I can only have one type of data. Integers, floats, so on. Pandas does not have that problem, but there is a requirement down a specific column. So, in this initial column, everything is an integer. In the next column, everything is a string. In the next column, everything's a string, and after that, everything is a float. So we have the same type going down our columns. Yes.
Wait, so is it better to use pandas when we're doing our midterms?
I would probably use pandas. That's why I'm showing it to you now.
Okay,
I wanted to have time to get through pandas first, but we were sort of time crunched. So I would use pandas. Here's how we use pandas. I could open nvim, or I can just Python 3. Import pandas as PD. PD inside of it has something called read_CSV. And I can actually just give it URLs to the best of my knowledge. And so there's the pandas data frame. Now there's a lot of ... ellipsis in here because the thing is huge. It's not all going to show up. But I can store this in something called df for data frame. And then I can fiddle around with it a little bit. Ooh, I should have done that first. Okay. So I'm going to set df equals to pd read CSV. I'm going to take the URL. The URL has to be inside quotes and inside parentheses. Then we can look at df. We can look at the head of df, perhaps.
The first 6 rows.
We can look at the df.info. And there's a bunch of ways we can look at this. But this is, I would like to point out, quite a bit larger probably than the taxes NP array we started with. We can put much more information in pandas this way, and it can still be kind of manageable. And we note, again, we have things that are integers. They're using object instead of string. That's fine. Floats, ints, floats, then a bunch of strings, and so on. Okay, so this is a pandas data frame. Okay. That is supposed to say names. That's not even close to names. Yeah. And you know what happens when we get a typo, right? It's time for monkey type. Okay. Are we all locked in? Are you locked in? You locked in? You locked in? Okay. All right, I'm going to do one attempt, and if you do better than me, you get 1 gold star, okay? Oh, no. My pop's not, okay. Ooh, rough day.
Oh, wait.
Did you get another gold star? I'm giving away so many gold stars in this class.
Gold star.
I'm going to run out of gold stars. Good thing gold's the world's reserve currency. Okay. All right. That break was brought to you by Monkey Type, who does not sponsor this class. Okay. All right. So, pandas. There's a few ways to use these CSV files. So I demonstrated straight from URL. I think I can also download this thing. Save as. I'm gonna put it. I'm gonna call it table.csv, and I'm gonna put it in my downloads folder. I can cd into my downloads folder. I can Python. I can import pandas as pd, and I can pd.read csv table.csv. I'll get the same result if I download the file and work with it. But I also can just grab it from a URL every time. This file's not that big. I don't necessarily need to save it locally. So I tend to like to use URLs for these purposes, though it can make the code look a bit unwieldy. What did I press? Crazy. Okay. This URL is pretty long, right? But we note that it ends in CSV. So that's kind of what's important here. Okay, fun fact. Someday you are going to find one of these CSVs on the internet. You're going to say, hey, I want to use that. Okay? You're going to do that. Maybe you won't. I think you will. And you will think to yourself, hey, okay, here is a web page that is associated with a CSV file, right? So you're going to say, okay, I'm going to take the URL or the address from this web page, and I'm going to try and load it in pandas. It's not going to work. df equals pd.read csv, open parenthesis, open quote, paste, close quote, close parenthesis, enter. Oh, this isn't a CSV file. What is this thing here? Save page as table.html, import os.system cat downloads /table.html. That's what this looks like. That's a web page, okay? Web pages and CSV files, different things. They might look the same to us because they contain the same content, right? The same information is present in there, right? Just looks different. Pandas really wants to read a CSV file, and the CSV file is right here. I click the raw button on GitHub. Are any of you in Data 151?
Yeah.
Do they send you to Kaggle all the time?
Yeah.
Yeah. So on Kaggle, there are already CSVs, I think, right? But I think if I go to Kaggle, and it's going to try and make me log in, and I'm not going to fall for it. This web page says it's a data set, right? But it's lying. The data set's actually all the way over here, right? What does dirty v3 path mean? Where do you click to get it? Okay, it's making me log in. Okay, don't use Kaggle. Okay, or do whatever you want. You should specifically do what other professors tell you to do in their class, right? Okay, cool. Oh, the machines, they're still thinking. Okay, this is how things. Now, you should be a little suspicious of how good this looks on the slides, and also of how conspicuously similar to Markdown this looks. Let's see. df equals pd.read csv. df.to markdown. How do you spell markdown? Mm-hmm. Oh, and it markdown formats it as a table. Now, there's a lot of information here. But that, in fact, is a markdown table. I know what you're thinking. You're thinking, oh, that's too much. Not to worry, I have a plan. mvim bear.py. To markdown. Wow, I cannot spell markdown. Python bear. This is markdown formatted. Oh, was that? I heard the sound of someone not believing me. Okay, I'm going to go to Dillinger. Is this Dillinger? Named after my favorite type of pickle. An American gangster. What? Dillinger?
Sometimes it does that where it's crashing out.
It's not the only thing crashing out. Okay. Look, it's a markdown table. Wow, for real?
What's wrong with it?
You're too powerful.
Is this FR? Okay. If this doesn't work, make a gist on GitHub.
What is it, gist?
It's like the gist of something. So people were making repositories and then putting like 4 lines of markdown in them because there was no other way to send someone a link to some markdown easily. And GitHub was like, calm down. Please start making gists instead. And I am a gist appreciator. Look at these. Look at these. I got gists for days. I don't even know what that is, right? 5 months ago, what was I doing? I was prepping for this class. That's the nuclear data. Diffusion models as data mining tools. That was my notes for when I presented in a class or talk. Here's some. Wow, look at all this. There's an answer key to the midterm I'm giving next class. If you ever take one of my classes, it's at very high probability the answer key to any test you're taking is on my gists. Does that bother me? No, look at all the stuff you learn like following this. Look, it's libgmp. I mean, what's this? There was a snow day class, right? So that's what I use for gist. It's like I need one of something, right? So very nice. A good way to share code. Okay. So anyways, you can make hint for your midterm where you're required to have a markdown table. This is one way to make markdown tables. Did everyone catch all those hints?
Yeah, hints were caught.
Okay, the hints were caught. Oof. I bet this would be a little more exciting if visual mode, I'm deleting everything. I got the D too. I'm going to get rid of taxes. I'm going to put in, I'm just going to grab this thing. I'm going to print df.to markdown, okay, of the periodic table. Python bear.py. Ooh, that's a lot of text, so I'm going to save that in something. Table.markdown. Okay, then I'm going to go back to my gists. And what am I going to do? I'm presumably going to add a file. Okay, I don't actually know how to upload. Whoa, no, I'm going to press the button. Okay, I'm creating a bunch of blank gists. I don't actually know how to do this. But I bet it'd be really cool if I did know how to do it, right?
It'd be so cool.
It'd be so cool. Okay, fine, we'll figure it out. Nvim, table.md, insert mode, Control A? No. Okay, so we're going to select everything by exiting insert mode. I'm going to go into visual mode. I'm going to do Shift G to go to the end of the file, and then I'm going to do $sign to go to the end of the row. I'm going to right-click that and copy it. That work? Table.md. Create public gist. Please work. It's okay, you don't have to say I'm the greatest, I already know. Okay. And I couldn't be the greatest without you, the cool, fun students that animate me to live stream losing my mind every Wednesday. Okay, data frames. They have row and column labels. You don't believe me, I can tell you don't believe me. Oh, column labels? What, there's also row labels? The row labels are one less than the atomic number? Maybe not the best example, right? But nevertheless, it's the example we have, right? Okay. Arrays don't do that stuff. They're not like that. Okay. Let's do some subsetting. that's not what I meant to do. nvim bear.py. Okay. So I got my data frame. What do I want to do to my data frame? Well, let's print only the names of the elements. Now, previously when I put things inside of the square brackets in this class, I always put a number there. I always put its address on a street. Data frames, they're not real. I know this surprises you, right? Because arrays are real, right? Data frames aren't real, which means you can just ask for someone's name and it'll give it to you. So specifically, you can ask for every element in your data frame and it will give you the data frame column. You do not have to give it the column by address. So let's take a look at what this does. Python bear. It's all of the elements, but it's maybe not how we expected to see them, or at least not how I'd immediately expect to see them. So there's a little bit of additional information here. I have the row name. I have the name of the element, and then I also have a little bit of extra information here at the bottom. It tells me what the name of the column is. It tells me how many things are in the column, and it tells me the data type, and that's the NumPy data type. So these are all objects, which is what NumPy uses when it can't decide what type something is. They're all strings. NumPy wasn't able to figure that out, right? So this is how I can look at a column in my data frame. I can also look at more than one column at a time. How am I going to do this? I'm going to go back to nvim, and I'm going to put two things inside of my address checker. I'm going to put the element, and I'm also going to put the symbol, the atomic symbol. Should I put something other than symbol? Any chemists want to check anything else? I heard someone say electronegative. Oh, atomic mass?
Yeah.
I think that's in here, right? Let's check the answer key. There it is. Boom. Okay. I have to make sure you spell it right. For real? Chat, am I cooked?
Probably.
I don't feel like I should be cooked for this. This seems completely fine to me. Is symbol gonna work? No. Wait a minute, they both have to be inside bracket. Oh, I have to put a list in there. Oh, I can't just put a bunch of things that are separated by commas. So, you can use multiple things, but you have to give them as a list. So, we can do, for example, column names, which equals element and atomic mass. And then we can look up those column names within the data frame and look at that. Oops. Okay, and we can see it that way. But it is much more common to just take this list. I'm going to yoink it. I'm going to paste it, and then I'm going to yoink this. I got to get rid of that. And there's two brackets there. So the point of this exercise is to show there's two boxy brackets, right? There's two boxy brackets when you want to have multiple things. And we can also add symbol just as easily. Now, if anyone who teaches literary theory is talking to you about this class, I would like you to say, when you ask what you learned today in this class, symbolism, okay?
Yeah.
Right, write that down. Why are the drapes green? Because of the chemical composition of the drapes, right? So we're doing symbolism today. Okay, very good, good job. Everyone's doing a great job. Who loves the transuranic elements? You're not a big fan of neptunium? You don't really like moscovium?
No.
You don't like nobelium? Well, I'm a huge fan of the transuranic elements, but since you all are haters, we're going to look at the non-transuranic elements. We're going to look at the negation of the transuranic elements. And I'm doing this for you because I respect you and want you to be happy and learn, okay? So don't ever say I didn't say that I said that. Okay, so we're going to look at the data frame, and we're going to look at the elements with atomic number, number. Wow, spelling number is hard. Okay, so So I'm going to look at the atomic number, and I'm going to say that it has to be less than 93. Because all of you are being mean to the transuranic elements, even though they try very, very hard to feed and clothe their families, okay? And here are the not transuranic elements. I think it'd be a lot easier to see them if we only looked at the names, element, and the symbols. This is okay. So what is happening here?
Oh, we're defining.
Yes. So this, beginning at DF, okay. Nope. There, oh, that's why, V. Okay. This is all of the atomic numbers in the periodic table. I'm going to look at the periodic table and I'm going to check to see if the atomic number is less than 93. So this is all of the rows in the periodic table for which the atomic number is less than 93. I'm going to use that to look up rows in the periodic table. And then this will be the periodic table ending at atomic number 93. I'm going to look at that, and within there, I'm going to look at what? I'm going to look for elements and symbols, and I'm going to look both of them up. And so this is the non-transuranic elements. That was too confusing. Don't worry, we'll do it step by step. Ooh. Ooh, I did something wrong. Okay. What is this? This is a vector less than. Okay? I look at the data frame, I look at the atomic number, I compare the atomic number to 93, and I output a vector that is true where the element has atomic number less than 93, and false where it has, and I have to say it this way, this is kind of tortured, does not have atomic number less than 93. So just the negation, right? It's kind of tough because it's skipping things, right? But right here at 92, it's going to change from true to false. I'm going to take these true-false values, and I'm going to use them as the index, and this is something called Boolean indexing. I'm going to get a list of rows and whether they are true or false, and then I'm only going to look at the rows where that is true, so this is going to stop at 92. Are you tracking that okay? Can I get some heads rattling? Would anyone like to panic? You want to panic? Okay.
Yeah.
What's your panic about?
I don't know. I kind of didn't get that, but yeah.
What did you get?
I did get that the first part where you're saying that like you're looking at the atomic numbers that are less than 93 and it's spitting out true or false.
Okay.
Because, you did a comparison
Mhm.
statement. So
Yeah.
if it's less than 93, then it's true. If it's not, then it's false.
Yeah.
But then I don't know what happened afterwards.
Okay. So, we're going to start with the Booleans. This is where we started. And these are the trues and falses, right? Now what I can do, and this is new information, I can use those trues and falses as the location in a data frame. So I'm going to say I want every part of the data frame where the thing is true. And the way I do that is I take the data frame, oh my gosh, why am I not in insert mode? Data frame, and I just use those trues and falses as the addresses I want. It's like, here's the list of houses I give to the realtor that I want to look up, or something like that.
So does it spit out only the trues?
It will split out only the trues. So we're going to do the data frame where the data frame's atomic number is less than 93. What is the last element going to be? 92 uranium, because 93 is false, so it's going to cut it off. We can cut much sharper. Let's only look at things that don't have a second electron shell. So that's going to be helium and hydrogen. That's where I run this. So I only get helium and hydrogen when I try and cut it 3. I'm going to say you understand that. Do you understand that?
No.
Okay. What don't you understand about it? That's not a useful question. Okay. Okay, if I asked you to find all of the elements where, for example, the number of shells is 2, could you do that? How would you do that?
Like, while looking at like a table, or
No, but using the code.
No, I don't. No, I don't.
Okay, I'm going to show you.
Okay.
Okay. We're going to check the number of shells. So I'm going to get rid of atomic number. Is it number of shells? Shoot.
Yes. Probably.
Oh my gosh, where is it? Number of shells. Okay. Number of shells. I'm going to check the capitalization. And I said I'm going to look for number of shells too. So I think you could have found this manually, right? That's cheating. I want that to be equal to 2. Let's just look at this now. And I'm going to take off the 2 data frames. So I'm just going to check to see if the number of shells are equal to 2. Here we go. So hydrogen, no, has 1 shell. Helium, no. Boron, 2 shells. Beryllium. And these are off by 1, right? So this is not element number 0. This is element number 1. I was going to put neutronium in here, and everyone hates that, right? Down here, this is, well, okay, I think this one's Moscovium, right? So Moscovium doesn't have 2 shells. Okay. So I have all of the locations where the number of shells is equal to 2. I'm going to take those locations, and I'm going to ask the data frame to give me all of the elements at those locations. So I'm going to look in the data frame at those locations where the number of shells is equal to 2. And I'm going to see lithium. I skipped lithium. Y'all let me skip lithium. I totally forgot lithium was element number 3. Lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and neon.
That makes sense.
Okay. I'm going to look around at all of you. I don't trust you that you're all tracking this, but that's okay. Okay.
Yeah, I got it now. And then the second bracket thingy is you're specifically telling it, oh, these are the columns I want to look at.
Yeah, we can look at specific columns. This is like pretty uninteresting because it's just going to be a bunch of 2s. But maybe it's more interesting if we look at symbols. Okay. Oh, it's symbol, singular. Please. And of course, we all remember Liebeb Knopfni, which is, of course, the second row of the periodic table. Okay. Well, they have discoverers here. Like, I'm supposed to know who Cavendish is? Prehistoric? I have no idea who that is. Okay. Very good. We can see how big data frames are. What's that mean? I have 118 elements, about which I know 28 things. You can also use shape with NumPy. No one cares. Okay. Sometimes you want to look things up not by name, but by address. And you can do that with integer location, iloc. This is super weird. So far in this class, every single time we've written something that could possibly look like a function, like df.iloc, we've always used regular parentheses. Every time we've just put something directly up against the name of a variable, we've used square brackets. iloc does both. The reason for that is it's still just looking things up by locations, but the default way to use the boxy brackets is already taken. So it's super weird. So I'm going to say iloc 10. I'm going to do 9 because I want to get neon. Neon is the 9th 0 indexed element. It is element number 10. This is going to give me neon, and I'm going to print out neon. And we haven't actually printed out one of the individual rows yet, but this is what they look like. It's going to be all of the different column information. So number of protons, for example. Oops. Sorry, what?
Is there an undo button?
Or the equivalent of an undo when you like just remove a bit of code even.
Oh, you can do U in NVim and when you're in command mode. So let me do an example. I'm going to delete this line,
Okay.
and then I'm going to press U, and it's going to come back. Can I put like, I don't know, 13? It does appear to have done that, yeah. Oh, it stopped at 12, so it's the same as the other ranges. Oh, that gave me the 17th column. So let's get the third column. So you can take slices in both directions. This is the atomic masses, which is the third column over. Because I did 9 to 13 by 3. Whoa, okay. I don't know what I'm doing there. Jeez. Okay. 9 to 13. And then by 3. 0, 1, 2, 3. So we got the atomic masses. This is 9, so that's 20.18. 20.18. So we can find the same thing in the spreadsheet. It's just a way to refer to sections of spreadsheets that are too big. I hope by now you're feeling like maybe if you opened this up in Excel, it would be too big to fit on your screen anyways. And maybe there's some usefulness in looking at subsets using these sort of filters. And if you're not thinking that, keep that to yourself. I don't want to know. I'm doing my best. I'm fighting for my life up here. Okay. Data frames are 0 indexed. Elements are 1 indexed. I'm sorry. I can't do anything about that. But we can, for example, take some samples. What am I doing? Where's NVim? Okay. Oftentimes, I don't want to look at all of my data at once because there's a lot of it. So I just want to look at the every 20th thing. And maybe I want to look at, what is this? The number of neutrons and the number of protons. No problem. Number of neutrons. Why are there 2 brackets here? Because I'm going to create a list of the columns I want to see, and then I'm going to look up those columns. So I need the 2 brackets. Number of protons. That probably works. What am I doing? I'm missing a closing parentheses. Really? Oh, I'm missing one of the boxes. Here, let me look at this. This will be easier to see. This opens with 2 boxy brackets, and it closes with only 1 boxy bracket, so I have to insert an additional boxy bracket. And then I can see the number of neutrons and the number of protons as the index increases. The interesting thing to look at here is the number of protons is increasing faster than, or the number of neutrons is increasing faster than the number of protons. Perhaps this is interesting to us.
Was the 20 that you were looking at it like 20, like the row 20 and the row 40? So you weren't looking. I'm confused.
Yeah.
I think, yeah, Is the third,
It's the same as a step size in a
yeah.
list. So I think when we've had like, this is a string of some kind. And if you want to look at every other letter in that, you take every second, or every third, or every fourth. We can do that with the elements too and just look at every 20th. And it's a way to look at a more manageable amount of them that's distributed evenly, sort of over where we're looking at the elements. Okay. It can also be interesting to do vector operations. Oh, no, it's fine. We like vector operations. So I can take the difference between the number of protons and the number of neutrons.
Wait, that actually might be how I do my midterm.
Yes, it might.
Focus.
Yeah, I'm going to need you to focus up when we get to this next class when we talk about visualizing these things.
Okay.
Okay. I'm going to spend 5 minutes walking around asking you if you're doing okay on your midterm. You're all going to say yes whether you are or not, because that's how students work. I don't know why you all do this. Then I will be able to honestly tell someone that I asked you how you were doing on your midterm today, right? So this is only plausible deniability for me. Now, if you actually have something you want to talk about on your midterm, you can do that, but you got to do it in 4 minutes, okay? Okay. Here I go.
Okay.
And adding might help me. It's up to you. Okay.
What was my,
How'd your midterm going? How'd your midterm going?
It's going good. I don't have it, but it's going good.
You don't have it? Yeah.
Yeah.
Okay, so, well, before I learned about pandas, I was using them.
That's fine.
But the thing is, I kind of want the,
Yeah, but I'm like more than following a lot of these. There's also the string, which is also.
You can also just like keep all assuming that and then at the end of it, turn that number array into a data frame and do anything left.
It's all because my computer. Sorry, restart.
Not bad.
You can't open the
I
terminal.
think I went to cusp of understanding, like.
Cusp of understanding, that's good.
Yeah.
Yeah, I've
I'm
had like
getting towards the cusp of
computer
understanding.
problems.
approaching the cusp.
Approaching the cusp.
Just because.
So the amount of understanding is increasing over time.
Yes, I'd say that's enough.
That's like impossible to see. I just turn some lights up. Right. How's your midterm going?
Good. I just need to figure out
I'd
how
say
to
so.
do my
Yeah.
Okay, cool.
Yeah. But yeah, if you need
Listen, I was wondering if you could post all the sheets earlier because I have a lab at 1:10.
I mean, mine
Yeah.
videos, right?
Or we could do another.
You like to go.
Even Thursday.
That is kind of long.
Yeah.
I know they're an hour.
I could choose to do like Thursday before cheese.
How you doing?
Yes, that would work.
Yeah. Or like do tomorrow early.
Yeah.
Because it seems like, this week a lot of people are going to need help. So
Yeah.
we'll do like a longer amount for more.
I think everyone's gonna come to the office hours.
Yeah,
Yeah.
definitely.
Yeah.
I think Thursday before chase.
Yeah, Thursday probably works the best.
Oh.
Because it's down at Customers chase.
Yeah.
Look at the sleeping.
Okay.
Not enough sleep tonight?
No, I woke up on that part.
Sure. Yeah. I can do Thursday before chase tomorrow.
To look at the
Okay.
best sleep I've ever had here.
You can always start.
The best sleep.
Yeah. Okay.
Love that.
I don't know why you all worry about it. I'm the one that actually worry about it.
It's alright.
I wonder why.
Good sleep after a good week.
Is that very good?
I'm doing all right. I had some
A lot of
technical
hard work.
difficulties with my computer. but
Didn't know
I'm
homework.
pretty solid.
I actually did some
Really?
I did my chem stuff.
You want my computer today?
Oh, it's a lot. Did you do your post lab?
Yeah.
The pre-update of it is a lot.
All right, you are all invited to come take the practice midterm in my next class.
Practice midterm.
Yeah, it's their practice